So in the last video, we decided that our goal to find variance would be a metric that expresses how good a predictor the average of a population is. And I'll go ahead and tell you that we're going to use golf scoring, meaning that the lower this metric is, the better the average is as a predictor. This also makes sense if we just think about the English definition of vary or variance. So for A, it's a good predictor, and we want the score to be low. So we want the variance to be low for A. For B, we're not so confident that the average of 4 is going to be a good predictor. B should be higher than A. And C, very low confidence that the average of 4 is a good predictor. So C should have a high variance. And I like to think about variance as the distance we have to travel to get to said average. So A bar, the average of A is 4. I'm going to go ahead and draw that line. And I'm going to call our score, our metric here, I'll just call it S for now. So for point A1, we have to travel 0 to get to the point. For A2, we travel 0, and for A3, we travel 0. I'm going to add up all these distances traveled and get 0. Let's look at B. So B bar, the average of B is 4. I'll draw that line across. And starting at the mean, again, we only travel 0 for the first point. For the second point, we travel 1. And for the third point, we also travel 1 to get to our observation. And this is 2. Okay, looking good. So B scores worse than A using golf scoring. Let's look at C. Again, average of 4. Draw that line across. So our score is, again, we travel 0. For C2, point 2, we travel 1, 2, 3. For C3, we travel 1, 2, 3, which gives us a score of 0 plus 3 plus 3 equals 6. Okay, so this is good. So now we have an idea of a way to calculate how much our population varies. A is 0, B is higher than A, and C is higher than both of them. So how can we think about this in a mathematical equation? I went ahead and I moved all of our observations into their own tables. So for student A, we have exam 1, 2, and 3, and he scored 4, 4, and 4. Student B, she scored 4, 5, and 3. Student C, 4, 7, and 1. And then I've also added 2 rows for each table, one for the sum. 4 plus 4 plus 4 is 12. The sum is going to be the same for all of these, 12 and 12. And then to calculate the average, this is just going to be a reference. We can do sum divided by n. And n is the number of observations. So that is going to be 3 for us. 12 divided by 3 is 4. 12 divided by 3 is 4. And again, 4. And we'll notice that this is also A bar, B bar, and C bar. We essentially calculated the average or the mean of each point. Now, the way that we can calculate the distance is first to think about just, well, distance from the average, which I'll do AVE. And I can write this as AI minus A bar. This is our A bar. 4 minus 4. So this is A1. This is A bar. 0. A2 minus A bar. A3 minus A bar. Sum these up, 0. And now I'm going to go ahead and do this sum divided by m, and I'll explain why we're going to do sum divided by n in a different video. So just trust me for now that this is a good idea. 0 divided by 3 is, of course, 0. Let's look at b. bi minus b bar. So it's 4 minus 4. 4 minus, 5. bi is 5 minus 4 equals 1. 3 minus 4 equals negative 1. And the sum of this, 0 plus 1 minus 1, that equals 0. Crap. And then 0 divided by 3 equals 0. So this is obviously a problem. Remember, we actually wanted our score to be 2 for B. I'm going to go ahead and quickly go through C as well. 4 minus 4. 7 minus 4 is 3. 1 minus 4 is negative 3. And again, we got a problem. 0 plus 3 minus 3 is 0. 0 over 3 is 0. So what happened here? So we did calculate the distance from the average.